Okay, we're going to talk about, this is starting on page 17. And what we've got is a situation where we're going to make a simulation. So let me kind of talk to you that a simulation is essentially the step-by-step process that somebody could follow to simulate an event. And then they could get similar results as you. This is like when we did StratMeCapped for the experimental design. StratMeCapped was a mnemonic device for all the steps to design an experiment. And we're going to use ELARSA. ELARSA is going to be the steps that we are going to, the mnemonic device for the steps we're going to follow to define all the steps needed to simulate an event.
Was this another paragraph thing?
It is another kind of like bullet points. We write them out. All right. ELUARSA. I say ELARSA. All right. Now I do have a song for that as well, and we'll do that in just a minute. But first of all, I'm going to kind of give you an idea of what's going to be happening. We're going to be given a random number table. And we're going to be using the digits on a random number table to simulate something happening instead of actually, for example, tossing coins. So instead of actually tossing the coins ourselves, we're going to simulate the events of tossing the coins by using these random numbers. A random number table is designed, of course, it's a set of random numbers. They are in sets of 5, and then they have a space, and then another set of 5. So those sets of 5s don't have any significance. They are just have a space in between those sets to make it easier on your eyes, as well as having that large space from line to line, because having all those numbers can kind of get jumbled whenever you're looking at them. All right. So we're going to go through the steps that we need to simulate something. But I will talk to you about this first problem. It's asking us to use random numbers to get a simple random sample. And if we want to do that, we would have to go through a whole involved paragraph of how to select 4 students from a class of 30. And I think that there's a much simpler way to get a simple random sample of 4 students out of a class of 30. And how would that be? How's a simpler way to get a simple random sample? Yeah, put the students in a big bag or put their names in a big bag, shake well, and pull out those 4 names. There, I said that in one sentence and not having to have a whole paragraph to describe how to do it with a random number table. So we're going to end up omitting these problems that are about a simple random sample because there's a much better way to do that. So let's go on to this problem number 2. This problem number 2 asks us, what is the probability for finding 2 heads and 2 tails if you toss 4 coins? So we're going to simulate tossing 4 coins and see the probability or the proportion of times we get exactly 2 heads and 2 tails.
6.25.
Okay? It does tell us complete 20 trials. So we've got to define what all of these things are. I think you have on your page before page 17, and let's see, I think I have it down here. I think you have this on your page in front of page 17, and this is the song. So we're first going to start each digit represents. So we're going to talk about what each number in the random number table will represent in relationship to our problem. Does it represent the child, the gender of the child you have? Does it represent tossing a coin? Does it represent a particular card, or the card that is pulled out of a deck of cards? Does it represent the toy that you get out of a cereal box? What does the digit in a random number table represent? And then we want to define, let the numbers be, so we want to define what those numbers are. For example, if it's heads and tails, I could maybe say, let's do odds and evens. And let the odds be the heads and the tails be the evens, okay, or however you decide to do that, because would that represent a 50% chance of landing on heads and tails? Would that coincide with odds and evens?
What, 1 and a 2?
You could do a 1 and a 2.
Or 0 and a 1.
You could also do, say, let the numbers 1 to 5 be something, and 6 through 9 and 0 be the other item. All right, so we're going to let the numbers be. Then we're going to define what random number table we're going to use and where we're going to start. So our song goes, each digit represents, let the numbers be, use a random number table, start here please. So let's do those 3 steps on our first problem on page 17 about the 2 heads and 2 tails. So here we go. What's the probability for finding 2 heads and 2 tails if you toss 4 coins? So we want each digit to represent what? A what? Each digit represents a coin toss. So when I say digit, I mean the numbers 0 through 9 on this random number table. Now, in order to represent heads and tails, that needs to be a 50% probability. Should I use, say, 1-digit numbers, or should I use 2-digit numbers? What kind of numbers would be best to represent, say, heads and tails on a coin? Do I need 1 digit or 2 digits or what? Yeah, 1 will work. Good, so we're going to do 1 digit. So we're going to let each 1 digit represent a coin toss. All right, each digit represents, let the numbers be. So let, what numbers? What do you want to equal what? Okay, let the odds, I got to make those tails. For some reason that just matches with me. Let the odds equal the tails, and the evens and 0 equal heads.
0 would technically be even. You could split it into infinitely equal groups.
Okay.
Exactly, he agreed.
All right, so each digit represents, let the numbers be. Use a random number table. Start here, please. Let's use the random number table above. So we're going to use the random number table above. And start at the top left corner. So I'm defining all the steps that somebody could duplicate similar results or the same results as me. Okay, that's the first 3 things. Each digit represents, let the numbers be. Use a random number table. Start here, please. Okay, now the next set of words says, a trial consists of, what do you ignore? Okay, so a trial means, you go look at, what, how do you examine your numbers? Do you look at a certain number of them and then stop? Or do you look at the numbers until you come across a particular amount of items? So a trial consists of, when am I going to be done looking at my coins and I am done with 1 trial? And then your response is critical. What do you look for? So let's address those 2 items right now. Okay, so what would a trial be on our problem that we're working on? Yeah, 4 coins. That's a trial. You toss 4 coins. That is 1 trial. So a trial consists of, you can write down tossing 4 coins, or you could say looking at 4 numbers. So either one. Looking at 4 digits. Okay. Now, do I need to ignore anything? Do I need to take out any particular numbers values? Are repeats okay? If I looked at 4 coins and those were 2, 2, 3, 1, is that is having both of those 2s in there okay? Yes, they are, because they're independent coin tosses. And so I don't need to take out numbers. Okay, so the repeats are okay. I don't have anything I need to ignore. How many trials will I do?
20.
Okay, it told me to complete 20 trials. All right, so a trial consists of looking at 4 digits. Well, let's come on up here and do that. If I go 1, 2, 3, 4, and I draw a line, that right there is the end of one trial.
And we did it 20 times.
And you're going to do that 20 times. Yep, 1, 2, 3, 4. So go for it. It's actually really not that hard.
I've lost count.
3, 6, 8, 16. At the end of the line, when you come across something, just continue on to the next line as if there was not an end. Okay, so there's the end of my 20 trials. All right, so what am I going to examine in each one of those trials? If I'm looking at this one little trial right here, what am I trying to figure out? Yeah, I want to look at how many heads and tails, so think odds and evens. So I got tails, 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 heads, okay. So that one had tails, 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 heads. So what is my response to this trial?
That's a fail.
This is a fail because what am I looking for here? What's the probability that I get 2 heads and 2 tails? 2 heads and 2 tails, okay? So a trial consists of looking at 4 digits, and your response is critical. What will you look for? So my response is yes or no to if I got 2 heads and 2 tails out of 4 coins. Okay? Response is yes, no to if I got 2 heads and 2 tails out of 4 coins. So let's go ahead and go on up there and run this simulation. So on this first one, the answer was no, because I did not have exactly 2 heads and 2 tails. So go through there and do yeses and nos. So my statistic is the proportion or average of what I'm talking about. And in this case, since my responses are yes, no's, then my statistic, my result is going to be a proportion, because it's going to be the proportion of times that I get a yes out of 20 trials. And I counted that I got 15 yeses out of 20 trials. Okay? That's probably inflated. All the other times I've done it on other ones was around 35 to 40%.
Wait, go back up on your thing.
So it'd be interesting. That one actually, this is the one time that I've got a really unusual outcome, and that's going to happen from time to time. Most of the time, no matter which random number table you use, or even where you start on the random number table. People will get similar results as you. Maybe not exactly the same, but in the similar vicinity. And we're going to try that on the next problem. I'm going to let you all start in different places on different random number tables, and we'll see how close we get to each other. All right, so your response is critical. What will you look for? The next part of the song says, get your statistic, man, 'cause I want to know. So that's our statistic, is our results. Get your statistic, man, which was 15 out of 20, 'cause I want to know, according to my simulation, about what does this show. So that's our conclusion statement, according to my simulation, about what does this show. So that's how we're going to write that.
75%.
According to my simulation, that's your cover your hiney phrase. According to my simulation, I expect to get exactly 2 heads and 2 tails out of 4 coins, 4 coin tosses, about 75% of the time. Now, I'm going to tell you, let's think about this for a second while you're finishing it out. According to my simulation, I expect to get exactly 2 heads and 2 tails out of 4 coin tosses about 75% of the time. As I do many trials, many trials, as I do many trials, many trials, that cumulative probability, it will settle down to the true probability. So I might be a little inflated right now. What is that? That tells me that. As you do many trials, many trials, the cumulative probability, it will settle down to that true probability. The law of large numbers, you see. Okay, so the law of large numbers. So if we think 75% is a little inflated, we just need to do more and more trials, and the true probability will come out. All right, that is the end of that problem. Let's, I do want to show you the video, so let's see if this does its thing without messing up the, I kind of, maybe I'll do this at the very end because I don't want to mess up the video that I'm doing. You know, sometimes I've played this video, and it is on the YouTube channel. I've played this video, and it's messed up the video that I'm in. Okay, I could do that. No, I'm still afraid. Yeah, I don't want to mess it up. Okay, so we'll come back and we'll play this video. Hold on. Let's go ahead and go on to the next problem on the next page. It's problem number 3, and we'll go through the steps with this one. Maybe now that we've done one together, this one will go a little bit faster. So here we go. Many couples want to have both a boy and a girl. If a couple decides to continue to have children until they have at least 2 boys and 2 girls, what would the average number of children that the couple would expect to have in order to achieve this goal? What would that average number be? Assume that the boys and girls are equally likely. So this would also mean that boys are 50% chance and girls are 50% chance. Okay, so that plays into our, let the numbers be. All right, so we want to have the numbers represent something. What's each number going to represent? It's going to represent a child that this couple has. And then we're going to define the numbers so we know if it's a boy or a girl. Now, do you think we need to use 1-digit numbers or 2-digit numbers?
1.
Okay, we do use 1 again because it's 50-50 chance. Let me show you an example of when you would use 2 digits. When we end up doing our assignment, and I'll actually kind of start you guys on this one, this problem where there's a 55% chance of winning something, you cannot represent 55% with just single-digit numbers. You can't say 1 to 5 or this. You can't say 1 to 5.5 because there's not a decimal. So in this case, when you have a percent like this, you would have to use two-digit numbers, such as 0, 1 would be that represented as a two-digit number. They all have to be two digits. So we could say 0, 1 to 55 is a success, and the rest of them would not be a success. What would the rest of the numbers be? 56 to 99 and 0, 0. So we'll talk about this problem in a moment, but I just wanted to give you, there's an example of one that takes two digits to represent that probability. So coming on back up here to our problem that we're working with, this couple that has it in their mind that they need to have at least 2 boys and 2 girls, we're going to let each one-digit number represents a child from this couple. A child from this couple. Okay, so each digit represents, let the numbers be. So what numbers do you want to be what?
Odd boys.
Oh, perfect. That's so totally exactly what I figured.
Why not
We're
just
going to
5
let
through
the...
4 be boys and 5 through 9 be girls?
Why would you have odd girls?
We're going to let the...
Girls aren't odd.
Why would you have 5 through 9?
Why not?
We're going to let the odds equal the boys and the
Well, 0, 1,
evens
2, 3, 4. Yeah, I mean, I find it much easier than having it different whether it's even or odd.
equal girls, because girls can't even. Okay, haha. Now, you know, it would be interesting. It would be interesting if, suppose, somebody else, let's say somebody else chooses a different way to represent this. For example, let 0 through 4 equal the boys and 5 through 9 equal the girls. That's somebody's going to do that. Anybody want to do something else? Like, how about this one? 1 through 5 equal the boys. 6 through 9 and 0 equals the girls. There's just 2 other examples of what you could do. Does anybody? What? Go ahead.
What's wrong with doing like 0 through 5 equals boys and 6 through 9?
Because 0 through 5 is 6 values, that would mean there's a 60% chance of something. 0, 1, 2, 3, 4, 5, 6 is 6 digits.
So what if you did 0 to 4?
That's what we did right here. 0 to 4 equaling the boys is 5 digits for the boys. Okay. So just for this experiment, let's have some people represent things different ways. So I'm going to do odds and evens. So here we go. Each digit represents, let the numbers be. Use a random number table. Start here, please. So now, in this case, so we're going to use random for the cases of this experiment. Let's have some people use the random number table above. Some people use the random number table below. Okay. I'm going to use the random number table above. We could even have some people start in the bottom right-hand corner. But I'm going to start in the top left corner. Start at the top left corner. Okay. All right. Each digit represents, let the numbers be. Use a random number table. Start here, please. A trial consists of, what do you ignore? Okay, so let's discuss this. When I look at a trial, am I just going to go to say, look at 4 children and see what they are? Look at 4 children and see what they are? No, we're not. The rules of this problem say the couple is going to continue to have children until they have at least 2 boys and 2 girls. So, for example, in this first one, I got girl, boy, boy, girl. Oh, ding, 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 ding. They actually happened to achieve their goal after just having 4 children. But the next trial, so then that would end that trial. The next trial is, let's see, boys are odd. Boy, 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 girl, girl. Okay, now, ding, 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 ding. I have now gotten at least 2 boys and 2 girls. See, they had to have 5 children in that trial. So, My trial consists of having children until there are at least 2 boys and 2 girls. That's what makes the end of a trial. So let's write that down. A trial consists of having children until at least 2 boys and 2 girls are born. 2 boys and 2 girls are born. Okay, now your response is critical. What will you look for? So that means whenever I look at, after I have done my trial, what is my result? What is my answer I'm going to write above this trial? Am I going to say yes or no, it was achieved? I'm going to say how many children they had to have to achieve that goal. So my first trial, the couple had to have 4 children to achieve that goal. My second trial, they had to have 5 children to achieve that goal, and so on. Let's go ahead and let you run 10 trials. You don't need to do all 20. So we will complete 10 trials. If it doesn't tell you that, that's a good guideline. Let's do 10 trials. And so let's take a moment and let you do that for whichever rule or whichever random number table you chose to do yours with. Okay, so I want to average all of those together.
Oh, that's good stuff.
So I'm going to add up those 10 numbers and divide by 10. And I add them all up and I divide by 10, and so I get 4.9. So that's the statistic. Get your statistic, man, because I want to know. Let me go ahead, and I had neglected on doing some writing here, so let me fill this in. A trial consists of having children until at least 2 boys and 2 girls are born. And the response, what was my response that I wrote for each trial? What was my response to each trial?
How many kids are you?
Okay, the response is the number of children it took, or it takes, to achieve their goal. We'll just call it achieve goal instead of writing at least 2 boys and at least 2 girls every time.
I got 4.4, so technically mine was better.
And then here we got our statistic. The statistic is you find the actual number, and it's going to be your proportion or your average. And depending on the question the problem asked, ours was 4.9. So now I write out my, according to my simulation, about what does this show, and that'll be my conclusion. So according to my simulation, the couple will have about 4.9 children, because this is an average, 4.9 children on average That's why you do keep it as a decimal to get at least 2 boys and at least 2 girls. Now, while you're finishing writing, I want to hear some other people's results whenever you use different rules or you used a different number table. Connor, what'd you have?
I got 4.4.
4.4. Who else got a different number? What'd you get?
5.5.
5.5.
Yours was bad.
Next. What? 5.3. Yep.
Yours was bad.
5.3. Anybody else?
Huh?
But look at how these numbers, are they not, they're not exactly the same,
Wonder what the standard
but they are not in
deviation is.
that vicinity. Yes. And guess what? Don't you think that all of these samples are going to vary slightly
I wonder what the
from
standard
sample to sample, but they will average out. I mean, they will settle down to the true average. Okay. That's it. That is the process of how to write out your rules so that somebody can perform a simulation. Now let's go on to the assignment.
We'll make number 1.
So yes, for your assignment, your homework is pages 19 to 22. However, the first problem is one of those simple random samples, which we know the best way to do a simple random sample is a big bag, and so we are not going to do this problem with a simulation. That's just a lot of wasted brain power. And pencil lead. We got to save that lead there. Okay, so let's do this second problem. Let's kind of talk through this, and I'm not going to do all of it for you, but I wanted to change this so that we do 10 trials instead of 20. It just, we don't need to do all 20. We're kind of just so on all of these, this whole assignment, please just do 10 trials or less on everything. If it says less trials, fine. But 10 trials should be the most you need to do, okay? All right. So let's discuss this first problem here. Why can I not erase that? Yeah, and 0, 0. That's how. Okay. All right. So here's this first problem that you're going to do. It's actually labeled number 4. I guess I didn't fix the numbering on these, but here we go. The World Series is the best in 7. So that ends when a team wins 4 games. Suppose that a sports analyst considers one team a bit stronger and has a 55% chance to win any individual game. Estimate the probability that the underdog wins the series. Okay? So I am going to be coming up with a probability. That's going to be a proportion amount. So you can think your responses are probably going to be yeses or nos because I'm going to have a probability of something. All right. So let's see here. Let's go ahead and kind of talk through this one. I need to represent 55%. Should I use 1-digit numbers or 2-digit numbers? 2-digit numbers. Okay. What is each 2-digit number going to represent in this problem?
Every individual team.
An individual, a team. Yeah, a game in the World Series. Good. So each 2-digit number, and I'm not going to write this all out, but we're going to kind of outline it for you. So each 2-digit number is going to represent a game in the World Series. Okay, so that's your each 2-digit numbers going to represent a game in the World Series. Okay, each digit represents now, and then we already talked about this, let the numbers be. So 0 to 1 to 55, what does that mean?
That's if they lose.
Oh, okay.
That's because it's asking if the underdog wins the series.
So, but since we need, yes,
That would be them losing. The underdog
Gotcha.
losing.
okay, let's do it that way. I think it's easy. I think for the purposes of the recording, I'm going to overrule that. But you know, you can go with, I'm going to say 01 to 55 means the stronger team wins.
Exactly.
It's going to be
Somebody's
simpler.
asking about the underdog winning the
Correct.
series.
But I'm going to write it this way.
Uh,
But you can write it your way, that the underdog team loses, stronger team wins. And then, of course, we already said 56 to 99 and 00 means that the underdog team wins. Okay, so each digit represents, let the numbers be. Use the random number table. Start here, please. A trial consists of, so I'm just going to find a random number table. There's 3 on the next page. I don't care which one you use. I'm going to pick one to just, because we're just doing, for example, how we would do this. So I'm going to start on the next page. Now, how long is my trial going to go? How am I going to do this? I'm going to start picking 2-digit numbers, and when will I stop?
and whenever you have 4 wins or 4 losses.
Good. You know how in the real World Series, the World Series will end when one of the teams has won 4 games. So when I do this, so like, if, for example, if this is the number 95, who just won that game?
The underdog.
Okay, so that's the underdog. I'm going to represent that, put a U under it. Here's the number 46.
That's a loss.
Who just won that game?
The other, not the underdog.
The stronger team. Here's number 88. Who won that? Here's
Underdogs.
underdogs won. Okay. Here's 74. Who won that? The underdogs. Here's the 11. Who won that?
Stronger.
Stronger team. Have we had 4 winners yet?
No.
Okay, keep going. 30
Stronger.
is the stronger. Oh, are we there yet? No.
Just went all the way to game
Then we
7.
got to go all the way to Game 7 in the World Series, 64, and that was won by the underdog. So that's how long a trial goes. A trial consists of playing games until a team has won 4 games. And we're going to complete 10 trials. So we just demonstrated one of them. What is the response? What do I write on top of this? I don't write how many games it took them to play. What do I write on top of this? Yeah, write yes or no to if the underdog won the World Series. So my response is yes or no to if the underdog wins. And in this case, it's a yes because the underdog wins. So that's the response that you are going to do. Yes or no. This one did not ask me what's the average number of games played until the underdog wins, or I don't know. Okay, so that's how you do that one, and then I'll let you finish it out. But that's your assignment. I just kind of wanted to get your brain thinking in the right direction on those, and we'll check those tomorrow and practice on those tomorrow.